sequential digital logic circuits. So sequential digital logic circuits. So what are those? They are used in memory elements and such other places where the output is also a function, or rather is a function of not just the current inputs but also the previous state or states, as the case may be. A real life example from your day to day life is a toggle switch for on off. Another good example is a channel surfing switch on a TV set. It's a very good example. Okay, so how are they sequential circuits? Let me explain that first. So you see, when we are see in a TV set, there is an on-off switch. You press it once, it's on. Press it another time, it's off. When you press it another time, it's on. So that means that the current is allowed to flow through the switch when the switch is off. Then when you press it, the current is allowed to flow through. When it is on and you press off, the current is cut off. Or we should say, if we speak more specifically, the current is dropped below a threshold level, a resistance is applied, the current is dropped below a threshold level so that the TV circuit stops working, you cannot see anything, and that resistance gap is filled up so that there is no or very little resistance, as little resistance as possible is allowed by the um, switch. So when it is in a off position, it is that means it is turned on. So you see the same switch. So we cannot compare this exactly with a fan switch, because a fan switch has two different positions for on and off, two different positions. But in this case, when you are pressing the toggle switch, okay, or even a fan, maybe even a fan switch, if you can look at it in a way, if you press the switch once, if it is turned on, it will be off. If it is turned off, it will be on. So that means, depending on the previous state, the output is different. Depending on the previous state, the output is different. So whether a turn will be switched on depends on whether it is off. If a fan is already switched on, if a TV switch, we're talking about TV switches, the TV switch, whether you will be able to turn on the TV or not depends upon whether it is off. If it is on and you press it, it will be off. So if it is off, only then if you press it, it will be on. Is that correct? So that means turning on and off is totally dependent upon the previous state. So that means it's a sequential circuit. It may not be a digital sequential circuit, but it is a sequential circuit. It takes into account the sequence of states. A very good example is the second example that we have, the channel surfing switch. It's a great example. So when you are pressing, it's on 0, 1 and 2, then 3, so the channel goes up, same switch. Okay, for example, if I show you the TV remote here, right, there are different switches for different channels, but look at this switch. This is a channel up. Okay, so when you do channel up, channel up, channel up, 0, 1, 2, 3, 4, 5, 6, 7, 8, etc., etc., goes up. When you do channel down, comes down. In fact, this is arranged in cyclic order sometimes, that if you are in 0 and let us say you have got 300 channels, then you have got 0 to 299 channels. Let's say if it is 0 and you press down, it goes to 299. Just like we faced in case of integer representation, it goes to the other side. Or sometimes it will just say it is in 0. In some organizations, it will say it is 0. It can't go down anymore. Similarly, when you go up and up and up, it is cyclically arranged. When it reaches 299, it will go to 0 automatically, with cyclically arranged. Or otherwise, if the arrangement is set to not cyclical, then in that case, it will just say no more channels, because we've already reached 299. Example. So these are toggle switches, we say, and these are nothing but sequentially sequential circuits, sequentially acting circuits. Right? Depending upon the states that they are in, they'll produce the output. So, that's the thing. This is a sequential circuit. Now, why do we actually need that in case of a computer? Well, as I said, that they are used in memory elements and such other places where the output is a function of not just the current input but also the previous states. You take, for example, an adder. What will be, say we just did adders last week, last week. So what will be the result of an adder, adding an augend and an addend? The answer is it also depends on the carry. Because if the carry is 0, then whatever you are adding, addend and augend, the result will be that. And if the answer is 1, if the carry is 1, that is, if you had a previous carry, then the result would be addend plus augend plus 1. You should remember the serial adder that we had seen. Okay, just let me show it to you once again, maybe. In that, we used to have just one sec. So in that serial adder, we used to have one register which is set for the carry, and when you are adding the two numbers, the carry is going into the serial adder and then it is fed back into the, never mind, I'll just draw it here. So look at the serial adder. So you had a certain register bits. This is the addend, the one added to, and this is the augend, the one which is added, and this is fed into a serial adder, a 3-input serial adder. And the next one that comes in is a carry. It's got two outputs. One goes into the carry, is a C t plus 1, and this one is a ST at any point of time. And maybe not, I don't want to call it. This is SN, this is Cn plus 1. So it's a n and n plus 1. So carry for the n plus 1 sum, and this is the Sn sum. This goes into a result register, which is actually the sum. Now see here, the carry has to be remembered here. Now who will remember this? How will you remember this? So you're producing a 1 or a 0 here, and this is going to be stored in the carry. Who is going to remember this 0 or 1? The answer to that is this is a sequential circuit. Okay. So that is the main thing. So this is where sequential circuits come in handy in case of the design and usage of digital computers. Simply, memory elements, they are sequential circuits. And if you don't have memory elements, and there are also other things, there are setting and resetting elements which have to remember. Toggle switch, for example. Okay, once you press it, it's on. Once you press it, it's off. So it has to remember whether it was off or it was on. So there's a memory there involved in there as well. Somehow you have to store what state it was in the last time. So that is why you need a sequential circuit.